All right, so welcome to MME 412, 512, which is Advanced Mechanics of Materials. I will be your instructor, Mark Steinbottom. My office is in U's Laboratory 408. My lab is right next door, U's 409. The best way to contact me is through email, which would be mark.steinbottom, mimeoh.edu. And my office hours for the fall of 2020 will be on Mondays from 6:30 to 8 p.m., Tuesday and Thursday from 10 to 11 a.m. or by appointment. So if you need to meet with me, the best way to meet with me or to schedule a meeting during office hours or outside of office hours is to go to um, the course syllabus page here, and you can go down and you'll see at a certain point, I think I passed it actually already. All right, so here's my contact info. Try this again. So here's my contact info, and then underneath for office hours, there's a link here to my Google Calendar page, and on this you can actually click on different parts of. Uh, you can see where there's appointments available. So if you wanted to create an appointment with me, you could just say what you want to do, and it provides in the description. It provides a link for a video chat where we can chat. We will not have everything will be online this semester. Um, so if you can't make any of the office hours sections that are currently available, you may do. You may meet with. You can see that my other meetings are also available on the calendar, so you can suggest the meeting time and send me an email with the suggested meeting time and duration, and we can try to set up a meeting that way. All right. So, um, so for this course, we're going to be using a student-focused learning model. So instead of you reading materials before lecture or before classes, I'm going to expect you to watch some videos and take notes of those videos before you come to class. During class, instead of listening to a lecture, I'm going to try to have activities and discussion boards for you to try to complete during the class time. Also during class time, you'll have a number of group projects that you'll be required to complete in the class. So you're going to be trying to use the time during class when everyone should be available to work on those projects. Um, and then after class, you're going to be expected to do some homework problems and try to do more complex problems as well as um, projects. All right. So, so all right. So the textbook for this course is Applied Strength and Stress Materials by Budinas. It is available in Best Library in a hard copy. I'm trying to figure out a way to make this a digital copy. If I find a way to make a digital copy, I will let you know how you can access it. Um, so in the meantime, one of the most important things that you'll need to be successful in this course is you'll need to access the lecture handouts. So in the lecture handouts have most of the critical information that you need. It has all the reading information, it has the quizzes and tests that are coming up. It has learning objectives for the class, homework problems and answers, and it also has example problems and answers. So you can access the lecture handouts on the Canvas site. So they will be posted typically on the syllabus or the home page underneath the date. We'll have the lecture materials, and you can just click on the handouts or the notes, and it should be just a PDF file that'll have all the introduction, have the important information that you need up front on the table here, like the readings, the assignments that are due coming up and any tests that are coming up. And then it'll have um, like the lecture topics, and it'll have any learning objectives that you're supposed to do, your homework problems, and it'll have any homework problem answers. So it should all be in there. So you can go, you can feel free to, I would recommend that you download and print each of these handouts before you watch the associated videos. All right. So in addition to the handouts, the other thing that will be posted on the website are the lecture notes for the class. So basically, you can think of this as being the filled out version of the handout. So this includes the most critical information from the lecture. So it's a good quick reference if you need to reference something during your while you're trying to do your homework. So if you look at the lecture handouts, what you'll notice is that they'll be have more filled out notes. It'll have additional equations and additional drawings within it. Okay, so so that all that information should be available all on the syllabus page. And then any assignments that are due will be posted on the right-hand side of this table. All right, so any questions or any materials that you'll need for this course should be posted within this table on the syllabus homepage. Okay, all right. So let me go back to the PowerPoint here. All right, and what we got, um, the last, I guess, so how you're going to be your grade will be evaluated in this course is, so I will assign homework problems, but they're going to be essentially on your own, or you might work on them during the class period. However, they are designed to mirror the material that will be covered in your quiz problems. So make sure that you do the homework. The tutorial, like the solutions to the homework will be posted on Canvas. If you have any questions, you can let me know. The quizzes are going to relate to your homework prior classes. There's going to be 12 quizzes that are going to be spread out throughout the semester. Um, uh, and the lowest quiz grade will be dropped. So if you have a bad day, it's okay. It's not a big deal. All right. Then there's going to be discussion boards of probably once or twice a week. These are basically very informal exercises to design to test your knowledge. You're going to submit to the discussion board. It says 3 to 5 here, but it's really 1 to 2 times, maybe 3 to 4 times a week at most. But the submissions are going to be graded based on a good faith effort basis. So the goal of these discussion boards is for you to try the homework problems and to get feedback from your peers and from your instructors on that work. Then the other part of this class is there's going to be a lot of extra, I guess, outside the class assignments. There's going to be 3 computational assignments. Each of them are going to be worth 5%. They can be sometimes they may be independent, or they might be sometimes be like in small groups. You'll have a case study, which will be one assignment worth 5%, which will be a group project. And then the last thing is you'll have a design or research project, which is going to be 20% of your grade. So the grade is going to be based off a report, a presentation, and a group evaluation. All right. So I'm not going to just to mention again just to iterate here is that homework and problems and there's answers are going to be signed after every lecture. It's expected that you attempt the homework problems, and then please seek help if you need it. The homework problem solutions will be posted on Canvas, and I just say it is very important for your success in the course, especially on the quizzes. Okay, the grading scale is pretty traditional. Basically A through F, nothing crazy. And then, so I just want to iterate something about academic dishonesty, but also more importantly, academic integrity. Please note that I understand that this is difficult for sure doing this class remotely. However, I'm willing to be flexible. If you are upfront with me about if any issues that come up. If you need an extension, if you let me know like 3 days or 5 days before that you need an extension, I'll be much more willing to give you an extension than maybe if you like did like 12 hours before or the night before. So please uh, try to do the main thing here is I want to give you good feedback on your work, try to push you to do more work and really introduce you into some more advanced concepts that this class represents. So any type of activity that prevents that learning process, I will have to report to the department chair. All right. So please, if there's anything that you're worried about being academic dishonest, please see me and we can talk a little bit more about that. All right. So this course has three main parts. The first part, which is about the first 5 weeks of the course, involves stress, strain, and strength theory. So it's used to develop a universal criteria for failure in engineering components. The second part of the course involves energy methods and finite element methods. So we're going to we're going to talk about how you can use these techniques to determine stress and strain within engineering components, determine whether or not failure will occur. And then the last thing will be you're going to learn about other topics such as composites, buckling, etc., that are not covered in your original strength and materials course.